Solving simultaneous equations for unique, infinite, and no solutions. For this question, we've got determine the values of m and n for which the equations below have, part A, a unique solution. The first step when solving these types of questions is to rearrange both of the equations to make y the subject. And so doing this, for the first equation we're going to get 2y is equal to minus 1 minus 3x, and now dividing both sides by 2, we're going to get y is equal to minus 1 on 2 minus 3x on 2. For the second equation, we're going to get 4y is equal to n minus m times x. And now dividing both sides by 4, we're going to get y is equal to n over 4 minus mx over 4. Now for part A, we need to find the values of m and n where we have a unique solution. Now for a simultaneous equation to have a unique solution, then it has to satisfy one condition, and that is that the gradients of the lines must be different. And so what we need to do is equate the gradients of each of these lines. The gradient of the first line is equal to minus 3 on 2, and the gradient of the second line is going to equal minus m on 4. That is, this is going to be the coefficient of the x term. And then we need to find for what values of m will these two gradients be the same. And so equating the gradients, the negatives will cancel out, and so we're going to get 3 on 2 is going to equal m on 4. From here we solve for the value of m, and so cross multiplying, we're going to get 2m is equal to 12. Dividing both sides by 2, we're going to get m is equal to 6. And so what this means is that when m is equal to 6, the gradient of the two lines will be equal. But to have a unique solution, we need the gradients to be different, and so m can be any value except for the value of 6. And so we write this as the value of m can be any value except for the value of 6. The value of n does not affect the gradient of the lines, and so as long as the value of m does not equal to 6, we will always get a unique solution, which means then that the value of n can be any real number, and we will still have a unique solution for these two equations. Part B, an infinite number of solutions. For a simultaneous equation to have an infinite number of solutions, then two conditions must be met. The first condition is that the gradient of the lines must be the same, and the second condition is that the y-intercept of each line must also be the same. From part A, we worked out that when m is equal to 6, the gradient of the lines will be the same. And so, to have an infinite number of solutions, the first condition is to have the gradients to be the same. And so therefore, when we have the value of m is equal to 6, this condition is met. For the second condition, we need the y-intercepts to be the same. The y-intercept of each line is going to be the constant. So for the first line, it's going to be minus a half, and for the second line, it's going to be n on 4. And so to have these two y-intercepts to be the same, we need to equate these values. And so we're going to get minus a half must equal to n on 4. From here, solving for n, we cross multiply, and so we're going to get 2n is equal to minus 4. Dividing both sides by 2, we're going to get the value of n is equal to minus 4 divided by 2, which is minus 2. And so what this means is that when n is equal to minus 2, we're going to have the same y-intercept. Therefore, when m is equal to 6 and the value of n is equal to minus 2, we're going to have the same gradient and the same y-intercept for both of the equations, which means then we're going to have an infinite number of solutions for this simultaneous equation. Part C, no solution. To have no solution, then two conditions must be met. The first condition is that the gradient of the lines must be the same, and the second condition is that now the y-intercepts of each line must be different. From part A and B, we worked out when the value of m is equal to 6, then the gradient of the lines are going to be the same. And so this is going to satisfy the first condition. And from part B, we also worked out that when the value of n is equal to minus 2, the y-intercepts of the lines are going to be the same. And so this means that we want the value of n to be any value except for the value of minus 2. This way, we're going to get a different y-intercept, which satisfies the second condition. And that's it for this question. Now that you know how to approach simultaneous equations, Try out some exam-style questions to test your understanding and to help you better prepare for your methods, SACs or exams. To do this, just log into the Maths Methods Club, and from the main topics select Algebra, and then from the subtopics select Simultaneous Equations and then click on Filter. This is then going to instantly group all the past Maths Methods exam questions related to just simultaneous equations. Go through these questions to test your understanding on how to answer these types of questions. This way, you're going to be better prepared and ready for your SACs or exams when it comes to answering these types of questions. Good luck, and I'll see you guys in the next video.